Welcome, everyone. My name is Neil Normando. I work with the Electrical Joint Training Committee, and we are located in Port Coquitlam out on the mainland. We are a training center primarily for the electrical industry, not only just for foundations programs, but we also do a lot of journey person and also upgrading for industry across the board. We are hand in hand with the IBW 213, but we also do pretty much a lot of training programs for the open industry as well. So today I'm glad to be joining you in terms of one of our key programs, which is the electrical vehicles infrastructure training, which concentrates on the best practices as well as the features of electric vehicle charging infrastructure, which is becoming more and more common. It's actually big practice now for a lot of industries to be getting into. And I'm just going to give you a brief overview of what we're training, but as well some of the key features that we do recommend for a lot of our contractors and as well a lot of our members to train into, because the equipment does come in as a simple piece of equipment that is just you wire up, you basically get your car connected to it, and you proceed from there. But there's more technicalities in terms of standards, codes, and technologies that actually are involved in the process overall. And depending as to the requirements of the business, the home, whether it's a single family dwelling or if it's a multi-unit residential system, then the needs actually are different. And that means that technologies also can be introduced as well for those systems. So in essence, when we do look at our program, it was specifically addressed for the installation and maintenance of EV charging infrastructure. And with intent, and pretty much as well with municipalities, as well as with Technical Safety BC, and overall any standards involved in British Columbia or even across Canada, because our program is available actually across the entire country, that we're dealing with the electrical code, we're dealing with standards actually applicable to municipalities as well as specific jurisdictions. So we're doing this for the installation in the safest and most cost-effective manner. So our program it focuses on the key details of how to do this for the safest way to do it, as well for the application of having limited to maintenance-free problems with the systems as well. So installation best practices, we're dealing with electrical code and jurisdictional requirements. It's kind of interesting if you look across the province, is that all jurisdictions have to follow basically the electrical code, which is a standard that is available actually in a format across the country, across the province. But then all jurisdictions may have some very unique applications specific to that jurisdiction. So for example, if you're doing an installation in Burnaby, or if you're going to be doing an installation in Victoria, that there are going to be differences between the two. We also have to keep in mind the emerging technologies that do come into play. And a lot of those emerging technologies have differing applications across the board for some of the jurisdictions as well. Some jurisdictions will allow some of the new technologies to come into place, some will not. And just depends actually as to how the installation is going to get done. This also goes into coordination with the manufacturer of the equipment, and as well the intent actually for pretty much like the placement, and as well as the utilities in terms of accessibility, and basically as to what the end product is going to basically deliver. The key idea behind our program is to introduce safety, and that is not necessarily just safety for the contractor, safety for the installer, but it's the end user to the product. At the end of the day, once power has been turned on, once everybody is ready to go in, the end user in fact is going to be the vehicle driver, the person actually who will be using the service. So that is our primary focus. That's why it is very heavily basically applicable to standards. And we never really want to go beyond that. Unfortunately, there are going to be circumstances where installations do get done without permit, that do get done actually without jurisdictional approval. And if anything does occur, then these issues do fall under guidelines that insurance companies will not necessarily follow through on. And interestingly enough, there's also the aspect of customer service, though. So from a contractor standpoint, we have to look at their abilities to be able to work with the customer, work with strata corporations, work with business owners, work with homeowners to deal with their particular needs. Unfortunately, one system will not fit all applications, just because not everybody's going to be driving the same car. Different needs are going to be required for their charging requirements, as well as basically a personal need actually in terms of the available circuitry. And with intent, if I be delivering this to contractors, I can get heavily into the technicalities of a system. I'll basically try to keep it relatively simple for everyone to at the very least be on the same page, but I'll be completely open to questions towards the end. If I cannot answer all the questions, then I will request that Wendy simply send those questions over to me by email, and I'll try to get back to you accordingly. Now, when we do talk about some of the best practices in relations to equipment specifications, that we are dealing with equipment that has a constantly evolving base simply because of consumer needs. I find that equipment changes because of the different needs of customers, whether that is faster requirements for charging, bigger vehicles, bigger batteries, or simply put, you have more users to the product. We are also going to be dealing with equipment standards, which is extremely important. One specific guideline for the electrical industry is standardization. I'm sure you all heard about CSA or Underwriters Laboratory. These are major players that do actually produce products in Canada. And these are anything in relations to the manufacturing applications to these products that they have to meet standards that are going to be applicable into Canadian territory. Now, it's not to say that you couldn't use products that aren't rated for CSA or UL, but they would have to go through an approval process with a third party that is actually available. But for the most part, you can buy a lot of equipment off the shelf that is in fact CSA or UL rated, or if there's other applications to that too. One of the big guidelines that really standardizes everything in our industry is going to be the electrical code. And if it comes down to the choice of selecting a good contractor, this is something that's really important, is that they have to understand that the electrical code guides their installation. So the specific requirements in very specific standards to the code, they have to meet them simply because they are guided by safety. They're guided by the standard of making sure the installation meets the needs of those code regulations, but as well, it also falls into the site specifications, such as the jurisdiction or the municipality that they're working with. For more important aspect is as well the technologies that require to integrate with the electrical industry. This is actually where it's starting to become a lot bigger, a lot vaster to the system, just depending as to if the location is set up with solar, if the location is set up with energy storage, such as batteries, or to say that the intent of using your vehicle as a means of generation for power. These are all very specialized skills for the industry, and it's unfortunately not a situation where you can just grab a contractor to do one job. It's more an idea of making sure that the contractor has the skills to be able to do the job, understanding the requirements by standards, codes, and as well the knowledge of their product. Another element is to also introduce building code requirements. So I was kind of focusing on our Canadian electrical code, which relates to the electrical industry. But then the building code requirements does play a big part in dealing with where the installation of these electric vehicle chargers are going to be located, whether they're going to be for public use, whether they're going to be meant for fleet services, if they're going to be in multifamily dwellings such as strata buildings and parkades. They have to meet those national building codes. So it's not just to say that I want to install a charger on the wall, and it'll meet those requirements. They also have to meet the building codes, because now you're dealing with accessibility. You're dealing with the requirements for anybody actually who requires more space, or it has to be able to reach certain points, and not so difficult to handle the machinery. As well as safeguarding of the infrastructure, which is big. If you're going to be putting any piece of equipment located in a parkade or a parking lot, or in just a public area, then that equipment is live. There's power that's going to be at that particular system. And the very last thing you want to do is introduce a moving vehicle in that infrastructure. So that's why there are safeguards put into place that's guided again by the building code. And more importantly is about notification requirements, meaning you have to have the proper signage. You have to identify the systems that are going to be available out there. Plus, there might be the additional facility if you're going to have like network systems, that do you actually have to displace it on a website, or actually has to be informative through the host services. These are constantly evolving rules that are being put into place, and by the next iteration of the Canadian Electrical Code, and as well as the next iteration of the National Building Codes, you will see an evolution of all of those rules. As indicated before, these rules do change based on consumer demand. So depending as to what's required from the consumer based on their on how they set things up, their usage. And quite surprisingly enough, it's also dictated by incidences. So if you have a constant of incidences that occur, whether it is cars damaging the equipment, whether it is a human that gets injured in relation to the usage of these products, then this is where you will have the evolution of this, because they will get investigated and they will essentially be migrated either a bulletin or an amendment to our codes. Now, our electrical code has a lot of provisions in it in relations to electric vehicle infrastructure. Not to bore you with the details, the book reads like a legal manual, and I won't get overtly technical again in relations to this. But one thing that is truly important, and this is pretty much common to a lot of electrical devices, is talking about the grounding and the bonding for those systems. So it's pretty commonplace. You can talk to any electrician, any contractor, or anybody who has knowledge of the industry. And this is one of their key focuses, making sure the equipment is rated by standard and is also safe through proper grounding means. Now, with the introduction of new technologies, say that your facility has the ability to produce solar, or to say that you have wind technology, or any additional means such as power generation, like even a generator that's on site, there has to be a form of safeguard interacted with the systems that come into play, because vehicles eventually will have the ability to become a power producer. And so if you think of how solar works, that solar is implemented to bring power into your home, to your business, to your multifamily dwelling. And in the event of an incident such as a power failure, then there are safeguards again. So this way there's no backfeed into the utilities. Well, the same will be for your electric vehicle. Your electric vehicle will have the ability one day to power your home in case you do have an emergency, kind of like a battery backup. But when that does come into play, then there are a lot of safeguards that have to be considered. And it's not that you can't prepare for it, simply because the electrical code has taken the provisions to incorporate this technology into play, but it's just making sure that everything is 100% safe for it. This is a big one. The contractor who is going to do your work, or if you're a contractor in this conference, then this is pretty much commonplace, but you are guided by jurisdictional requirements, and usually those jurisdictional requirements will supersede your electrical code. And these are critical because you can't just skip it. You think to yourself that you know the regulations, and this is pretty commonplace for a lot of contractors. Although I have personally dealt with a lot of contractors who haven't had a code upgrade in a few years. And when it comes to some of these new requirements for infrastructure, specifically around the EV infrastructure, it's very new to them, and how to incorporate them with the rest of the code is quite important to also understand. So some of these specific requirements for EVs is based around emerging technologies, as well as the needs for the users, as well as the needs for the municipality as well. As an example for that, I myself, I live in the jurisdiction of Burnaby, and the electrical code, as an example, is only requiring for new, if you are planning on putting an EV charger system, or basically there is going to be provisions for a brand new home, you have to provide circuitry, but at a minimum of 20 amps. The municipality has changed that. They're saying that we're going to supersede the codes, and we want you to put an outlet for 40 amps for every parking stalls, unless there's other technologies involved. So these are really important to know and understand. Now, I understand that this is also in relation to the island, and I believe that there are going to be jurisdictional requirements for pretty much a lot of the municipalities and jurisdictions. So this way, it's good to understand what they're all about, simply because they make up the rule. They can basically say no to an installation just because it doesn't actually follow the proper provisions as well. There are 9 electrical jurisdictions in British Columbia, and technical safety does essentially cover the majority of them. And then when you look at the Lower Mainland, then after that, it's usually by city for the most part. So if you do have a contractor who ever questions that, one really good resource is going to be to visit Technical Safety BC, or simply just the website for your municipality. And they are more than helpful to pretty much answer any questions you need. I recently had an opportunity of doing one of these courses, and really, there was actually the Fraser Basin Valley group actually was there auditing my course. They had a really good question about owners who request for quotes from multiple contractors. So essentially 3 contractors came across the table. Not only did they provide, like each contractor provided them with a quote, but all the numbers were different, all the requirements were different, and it just left the owner really confused as to actually what to do in this case scenario. Which one do I trust? Which one do I pick? Do I go with the most economical one? Do I go with the most expensive one, or middle of the line? And my answer to that would be to simply educate yourself with your jurisdictional municipality. So if you in fact have you live in a city where you simply need to deal with city for electrical questions, call them, because at the end of the day, the inspector is the one who is going to be saying yes or no to the installation. So this is really one of those outlines to say that they can definitely help you out. They won't tell you which contractor to use. They will simply identify that, they're basically, these are the requirements for your space and location. Now, moving over to a little bit more of the applications of electric vehicles. Well, for one, electric vehicles actually haven't been available for over a decade. So that's pretty complex. Vehicles have been on the road, they require charging, everybody's happy. The biggest thing that's actually changed in the last decade is actually the evolution of the EV charger. And so with the increase of electrical vehicles on the road means that there is going to be a higher demand for EV infrastructure. This is simply to support the consumer's needs, but at the same time also opens up an entirely new industry simply because of the evolution of technology, but at the same time, where the locations are going to be, how the support's going to be for those systems, what do you do for maintenance purposes, who owns the systems, and the list goes on. Now, most importantly is going to be the integration of this infrastructure in not only new buildings, but it's going to be also the integration into existing buildings. And this is actually quite important. And there's it's multifaceted in terms of like how to make the decision to have EV infrastructure into existing buildings. A lot of times when you're doing a brand new building, well, it's already been outlined. Like you actually have to put in the part of the infrastructure for that EV infrastructure in place because it's required by either municipality or by the governing codes. But when it comes to single family homes, to multifamily units or commercial spaces that are existing, then the requirements are going to be a little different simply because you have to understand, well, does the facility actually have the ability to support new electrical infrastructure? How do you move around those parameters? Who do you communicate with? Do you also apply with the utilities, how it all plays out? And this is where a good contractor will have this knowledge, understanding that they may have to do or get a 12 to 24-month report as to the utilities of the facility to determine if they will have enough energy requirement for supporting the infrastructure. The requirements by building code, how many units can they actually put into place? Do they require accessibility for those systems as well? And then to also provide knowledge to all of the incentives that do come into play when you are going to be using this infrastructure. The government of British Columbia, as well as the government of Canada, have a lot of incentives, not only just for the purchasing of EV infrastructure, but also for the installation. And this is highly beneficial because it can help to reduce the costs of putting up infrastructure, whether you're going to be doing at the very low level systems or at the high level systems. Now, existing homes and businesses do have limitations. This is pretty commonplace because if the home's been in place for however many years, someone may have decided to put extra infrastructure in their house as it is. They put a new hot tub, bigger appliances, they added more lighting, and simply you're starting to load up those systems quite significantly. And the same goes for any type of home or multifamily dwelling, and the same for commercial spaces. So this is where a customer needs analysis needs to be presented. So you communicate with utilities, you communicate with the jurisdiction to determine exactly how you can proceed. This is usually done by your contractor that will facilitate those decisions for you. And once you do have that information to back you up, then this is pretty much what you're going to use for the planning. To take advantage of those incentives, as I indicated, a plan needs to be put into place. You do have to do an EV ready plan that is an itemized list of what kind of equipment you're going to be using, the manufacturers you're going to be using, the amount of energy available, supporting documentation. It's kind of like a business plan, but pretty much for the installation of EV infrastructure. So a lot of parties can actually be into play with this, but the most common one is going to be the utilities. And for us, it'll be primarily BC Hydro. In the interior, you do have another player, and that'll end up being FortisBC. And their plan is very similar, where you do actually have to go through those same steps. Now, this is where it gets very interesting. We're dealing with new and emergent technologies for EV infrastructure. I'll be honest, to connect an EV or a piece of EV equipment is relatively simple. I can coach anyone to do the installation from mounting to wiring and pretty much getting it ready for the end user. The only thing is that if there is now a requirement where you've got to increase the amount of units that would charge multiple vehicles, is to also understand if you have the capacity in your facilities to be able to manage that. And this is where new technologies have come into play, which is referenced as energy management. So think of it this way, where you're taking a receptacle that you find on the wall, and you have a small hand of devices, from chargers, from lights, from just random pieces of equipment you need to plug in, but you've only got the one outlet. Well, the answer to that would be, well, let's add an extender, or pretty much like a power bar. And so this way you can plug in multiple units simultaneously while using that same circuit. Well, you can easily do that and stay well within the limitations of that circuit, so you won't trip the breaker. But there will be a point where you will add too many, and your breaker is just simply going to say no and will eventually turn off. Well, this exists in the EV world as well. And this is where we can use energy management, simply because your facility, like the existing building, whether again it's going to be a multifamily unit or a business or for commercial fleets, they might not have enough energy to support the amount of units you want to put in for that system. It doesn't mean you can't. It just means that you now need something like an intermediary that allows you to manage all of that. Whether the power is going to be allocated by simple load switching, that allows to say that vehicle number one is getting charged for like 5-10 minutes. And then after that, the system is going to switch it to vehicle number two. So this way, everything is being shared and you will never overload the system. There's options like load sharing. Then there's these load management systems that are without monitoring, some that are with monitoring, some you have external monitoring. So meaning that you have a host service. So these systems do communicate via GSM or cell phone, I guess you reference it as. And the systems actually are going to be regulated to make sure that you never exceed the circuit that it's plugged into. So this is just a matter of being able to share one circuit for multiple vehicles through a simple integration of energy management. This is the way that a lot of single family unit systems are actually doing, or you can do it for single family, but you can also do it for multifamily as well. And why this is integral, why it's important to understand the technology plus the equipment you're using, is you have to take in all the factors that are applicable so you never damage the equipment, that you don't damage the circuitry, and most importantly, that you pretty much don't cause any type of injury or pretty much damage for the building in terms of circuitry failing and so forth. So I can keep talking about this for the next hour because there are so many elements, but it's one of the most important things that's transgressing through our systems today. That's actually the most important in terms of EV charging infrastructure. And again, the building code does have the provisions for this. So any contractor who goes into this business should be very versed in how this applies. So I did make mention about some of the regulations and some of the standards that are applicable out there. And it's again, all because of safety. So when we're dealing with CSA Group, which is the one that does have the electrical code in play, as well as some of the building codes too, you do have not just the municipality, but as well our board, which is Technical Safety BC, that mandates a lot of the rules and also regulates a lot of the licensing for contractors as well as for master electricians. And then we cannot forget about WorkSafe BC, that when you are essentially dealing with job sites, that they pretty much mandate a lot of the specifications related to the installation as well as the people working there as well. So now just talking about numbers to kind of give you a bit of a scope and idea as to what we are dealing with, why safety is very much paramount to these systems, is that if you, the end user, have to plug in a vehicle in or actually work in vicinity to any of these systems, that this infrastructure does apply at 3 levels. We have your very simple level 1 EVSC, which is your pretty much your system that will apply at approximately 16 amps, 120 volts, relatively innocuous and not overtly, it's not the one that's going to cause the most damage of any sort. We do have a level 2 systems that can go up to 80 amps. So now we are talking about thresholds that is almost equal to what an entire house's equipment support is. And that is relatively significant if you think about it. And so those are going to be at a higher voltage. So now we're dealing with systems that are a little more, a lot of safety has to be put into place. And the considerations to, again, as indicated before, grounding and proper installation is paramount. But now we're jumping into a much larger system, because now we're dealing with not only fast charging systems that you will find, whether it's going to be at the airport, at a grocery store, at a mall, or at a private business. So the level 3 can be in as low as 400 kilowatts, or sorry, up to about 400 kilowatts at about 1,000 volts DC. And loosely translated, we're talking about vehicles that can take in the upwards of 400 amps on the charge. Albeit this is going to be more at the commercial / fleet level, but regardless of it, it is still a significant amount of energy that has to be taken into consideration. Now, to give you a bit of an idea of what we try to teach some contractors, whether it's just going to be a single electrician or companies, is all about the safety considerations when it does come to not just the installation, but as well when we're dealing with maintenance and as well the coordination of repairs and just simply the installation as well. So we do have really a nicely set out and imposed guideline that we're trying to at least maintain electrical safety for the installer and the end user. And one of the biggest things to understand as well is the minimizing of shock and arc flash hazards, which is detrimental to pretty much the entire industry and as well to the facilities being installed into. You really don't necessarily want to deal with that personally, because, well, it means that something actually failed at that point. I have sat down with some engineers at Technical Safety BC, and they are pretty much referenced as forensic investigators to incidences, whether it's going to be at electrical level or pretty much anywhere across all industries. And the reason why they do exist, and the reason why I had a talk with them, is because they were trying to find out the weak points on EVSEs, or the electrical equipment. And surprisingly enough, not a lot of issues actually have occurred that related to either injury or death in the past. And this is just a testament to the standards that are being applied to all these systems. There's a lot of safeguards that are put into place when you are dealing with EVSEs. Also the installation, that it's also very integral how it's installed. And when you are dealing with these installations, the inspections that do fall behind them as well. So this is testament to all of these guidelines being followed, and as well making sure that everything is put into place. So this way we keep the forensic investigators in their offices and not on the job sites, to make sure that they can investigate where the problems are going to be at. So this is why we impose guidelines. We impose these methodologies for installation and as well as maintenance, because like anything else, they are equipment, there's mechanics behind it, and there are parts that could fail, and they simply just need to be repaired and be put back into service. One other aspect that's really important from a contractor's standpoint is their ability to actually work with the customer. So it plays into the whole idea of being approachable. It plays into the idea of knowing the content, the materials. So this way the individual understands what's actually your customer needs are going to be. Plus to understand that you have to coordinate with utilities. You have to also guide the installation based on the municipal authorities as well. Understand what the customer is going to be requiring in terms of their infrastructure. So it's not to say that customers down the road, you pretty much can duplicate the installation to a new building. Not so much the case. You kind of have to understand what their needs are going to be based on the facilities, plus how many vehicles are required. and as well as to accessibility needs. But most importantly, that we also try to guide a lot of our recipients to deal with stratas. And that is getting an understanding that you have to not only understand the customer, but you also have to be able to convince a crowd of the needs, of the requirements, and to be able to identify all the benefits that do come into play, whether it's going to be from the green initiative to the incentives to having EVSEs in your building, and as well as the basically like the choice of system that you want, whether you want to do it from a monetary standpoint, whether you actually want to do it for where it's monitored, or if it's just going to be freehand just for the users of that facility. And a big one to also know is the guidelines actually to your product, and to understand who the players are out there, the ones that do have the ability to be installed in Canada, the ones that actually will meet the needs for energy management. I did list out just a small hand of these. This is just but a fraction of the systems that are out there, from Flow, Ad Energy, EV Duty, and ChargePoint. They're pretty big players in the field as it is. Not to say that they're the only ones, but the industry is a little bit like the Wild West right now, that you're having a lot of companies that are bringing in their products. They're getting them certified, but it's just choosing the one that best suits your needs. So having an installer understand what is actually out there, what they can do, is all critical. And most importantly is that you may have initiated the very first step of doing the installation, which is great. If you've gone as far as that, I applaud the idea that you've done this initiative, and it's also important to understand that these systems do need maintenance, simply because they are going to be used by an end user. I use the analogy typically of like when you go to a service station and you want to put air in your tires. The coil of pipe that you have usually is never really put back up properly. Usually it's going to be lying on the floor. Cars have driven over it. The pipe is kinked. The compressor is damaged. Usually a lot of public facilities, this is a relatively commonplace. So this is said to be true with EVSEs as well, depending as to the system that you have, whether they're using retractable cords, or if it's just going to be loosely handled cords that can be put onto the ground. There's damage that's going to incur. And an effective system is the one that's going to be the one that is maintained, and usually that does require sometimes a maintenance program with a contractor, that they can come in, take a look at it every single year, make sure that all the parts are still functioning, and pretty much sign off on them, so this way they can actually last the remaining year as well. Now, when it comes down to all of those incentives I was referencing earlier on, and to deal with your multifamily unit systems, your commercial spaces, the whole bit, the EV Ready plan is the one that is going to allow you to take advantage of those gains, those incentives that are provided by the federal and the provincial governments. There was a pretty big change recently. More money was allocated to not only just the product themselves, but also the installation. And it depends as to how many you do have, but significant amount of money can be given per install that can bring the cost down significantly. So it definitely pays in dividends to be able to go and visit those sites. There's actually a slew of sites available online specifically for British Columbia that identifies a lot of these steps. But what you will potentially be hearing is the EV Ready plan. This is the requirement for not just the utilities, but as well for the commissions providing you with those incentives, that there has to be one available. So this way it can actually be documented and making sure that you are providing the proper product for that facility. So that is pretty much the scope of our program. Thank you very much for the attention. I really appreciate your time. I am completely open to questions and answers or any of the sorts.